When we're writing balanced chemical equations for Bronsted acid-base reactions, we need to imagine a beaker of acid that is already dissolved in water and has reacted with water to whatever extent based on its strength, and a beaker of base that's already dissolved in water and has reacted with water to whatever extent based on its strength. So to write accurate balanced equations, we need to use what's really in those two beakers. We need to use what we will call the primary acidic species and the primary basic species. If we have a beaker that's labeled 1 molar HCl, we need to ask, what is the primary species in that beaker? Let's look at our acid-base chart. We can find HCl on the acid side of the table near the top. You'll notice that the entry says HX, where X equals iodine, bromine, and chlorine. So HCl is on this line. The value of Ka is much greater than 1. We're reminded that all of the acids above the thick line near the top of the table are strong acids. They all react extensively with water to form hydronium in their conjugate base. In other words, the balanced equation for the reaction of the acid with water ends up mostly products. So in this case, the primary species in the beaker are hydronium ion, which will be the acidic species, and chloride. So for reactions involving solutions of strong acids, we'll want to use hydronium ion in the balanced equation. What if we have a beaker that's labeled 1 molar HF? What's the primary species there? Let's go back to the acid-base chart. As opposed to HCl, which is above the line near the top, HF is below the line. Its Ka is less than 1, so it is a weak acid. While weak acids do produce some hydronium, they do not react extensively. So the balanced equation for the reaction of HF with water ends up with mostly reactants. So for HF, the primary species in the beaker other than water is still HF. This will be the case for all of the weak acids. Only for the strong acids will the primary species be hydronium. What about ammonia? What's the primary species in a beaker labeled 1 molar NH3? If we look for ammonia on the table, we find it twice. First on the acid side, then on the base side. But we're reminded that the two acids listed below the line near the bottom of the table are really not acids at all. They appear there simply because they are the conjugates of the strong bases amide ion and oxide ion. The bases above that line are weak bases. This means that the reaction between the weak base ammonia and water is not extensive, remaining mostly reactants. Now, that doesn't mean there is no hydroxide in the solution. Ammonia is a weak base, but the primary species is still NH3. Finally, what about a beaker that's labeled 1 molar NaOH? We don't need to go to the acid-base chart on this one, since we recognize this right away as an ionic compound. Therefore, the primary species in solution are sodium ion and hydroxide ion, with hydroxide being the primary basic species.